All right, we got a physics problem here I'm going to try to help out with. We've got in the first part, we've got a 11.9 kilogram toy truck that moves at a constant acceleration of 3.3 meters per second. And the question is to determine the net force that is responsible for that acceleration. Okay, so it's important to know that if the object is accelerating, we know that the net force on the object can't be zero, and that net force is calculated according to Newton's second law by taking the mass of the object and multiplying by the acceleration that that object is experiencing. So this turns into a really pretty easy question, because if we know what the acceleration is, A, which is 3.3 meters per second, should be 3.3 meters per second squared, and we know the mass of the object, then we can determine the net force on the object. So it's just a matter of taking 11.9 kilograms and multiplying it by 3.3 meters per second squared. If you want to find the weight of the toy truck, weight is determined. Weight is equivalent to talking about the force experienced, the force of gravity experienced by that object. So in order to determine the weight, you just find the force of gravity acting on the object, which is done by taking the mass of the object, 11.9 kilograms, and multiplying by the acceleration due to gravity. Some textbooks list this as like 9.8 meters per second. Some list it as 9.81 meters per second squared. So it just depends on what value your classroom teacher is using in terms of like how you calculate that number. Okay, next, problem 2. You've got the Hulk. He's standing on a bathroom scale. And when the bathroom scale begins to move, it reads 9,000 newtons. And we're to determine the magnitude and direction of the elevator's acceleration. All right, so the acceleration is actually the magnitude, I'm sorry, the direction of the elevator's acceleration is the part we want to tackle first. So I drew a little illustration here showing the two forces that the Hulk is experiencing. First, he's got his weight. He's standing on the scale. And he has weight because he has mass. And then there's a second force, which is the normal force. And this is the force that essentially a scale is reading. It's reading the force. So this normal force represents the force with which you are pushing down on the scale. And so depending on how big or small this normal force is, will determine what the scale reads. In most cases, by the way, if you're not standing in an elevator, this is equivalent to the force of gravity. But it's not in this case. If the scale reads 9,000 newtons, I can already tell that's way bigger than his weight. And so this normal force must be way bigger than the weight of the Hulk. Since I know that the normal force, and there's only two forces acting on the Hulk here, is the normal force and the force of gravity. Since I know the normal force is bigger, the elevator must be accelerating upward. So we've got the direction part of the second question figured out. In terms of magnitude, it's a matter of calculation. So the first thing we have to know two things. We have to know the weight of the object and the normal force. The weight is, again, calculated by taking the mass times the acceleration due to gravity. There's the value for the force of gravity. And then the normal force is known to us. We're told that the scale reads 9,000 newtons. And so, again, this is an application of Newton's second law. Newton's second law says that the total force experienced by an object is equivalent to the sum of the individual forces acting on it, which is also equivalent to the mass of the object times the acceleration that object experiences. We're interested in finding the acceleration, So solving for acceleration leaves you with Fg minus Fn divided by the mass. And so at this point, all you have to do is plug in your values, and you've got your answer.